So, because they most directly map to x and y values, the types of things that we're most used to working with, and the type of things we are going to use a fair amount in this class and beyond, we generally focus a bit more on sine and cosine than the other four trig functions. Not to say that the other four are unimportant, it's just that a lot of what we discuss can be seen as through the lens of these two, and a lot of useful things happen to these two that can then be reframed to the others. So these are what we really spend more time on. We're first going to talk about the general behavior in terms of domains and ranges. That is, the types of things we can put in and the types of things we can expect to get out. Where when we're talking about sine and cosine, they are, in a sense, defined in relation to the unit circle. So if we want to think about what the domain of each is, we're thinking about amounts of spin. We're thinking about how many degrees we can put in, or how many radians we can put in. So it might be natural to look at these and say, well, shouldn't the domain just be 0 to 2 pi, including both ends? Because you go 0, go to 2 pi, you end up right back where you started. So does it really matter to go any further than that? Would it matter if we wanted to go clockwise instead? We'd still be describing the same thing, just in a different way. And the answer to that question is, actually, it does make a difference. We do want to leave ourselves open to those possibilities, and that hints at an important property of the trig functions that we'll see later called periodicity. That is, they repeat behavior at certain ranges of values. Well, I should be careful about the word range in this way. But the point is, just because we end up back where we started after going through 360 degrees or 2 pi radians, nothing says we can't keep going. We'll just end up in the same sort of places. So we say that the domains of these functions are negative infinity to infinity, excluding, because you can't include infinity in this context, to say that we can put whatever we want in there. Now we're going to see that there are a few important values, and many values are going to be not quite but almost meaningless outside of specific contexts, but really anything can go in. Now as far as what can come out, that's really where the thought that we're working from the unit circle comes into play, or at least it comes into focus. Because if we're looking at these in relation to unit circle behavior, we have to understand that what we're doing here is describing a component of radial measure in terms of angles on the unit circle, right? So whatever we put in, this tells us something about the x component of the associated radius, and that's something about the y component of the associated radius. But for the unit circle, we don't have a whole lot of options for the radius. The most you can be is 1, and if you want to be picky about the direction, the least you can be is -1. So, for all of our options for what we can put in, the only things we can possibly get out are along the range -1 to 1. And the next thing we're going to look at is describing the behavior of all of our trig functions in terms of one of those important and commonly seen values, 45 degrees or pi over 4 radians.